Okay, so today we're going to cover section 5 of chapter 2, and today we're going to see properties of algebra. These properties of algebra, we're also going to tie them into our geometry. We're going to apply them to segments and to angles. So here is our first properties, and we use these properties of equality when we solve equations. So the first one is the addition property. And all this basically is saying is you can add the same number to both sides of your equation and it stays an equivalent, or it stays an equal equation. Subtraction property of equality. This is where we're going to subtract the same number from both sides. And then the multiplication property of equality. This is where we would multiply by the same number on both sides of our equation. And then lastly, the division property. And here we would divide by the same number on both sides of the equation. Notice this little disclaimer here that C can't be 0. Just know that you can't divide a number by 0. It's undefined. So I'll show you some examples of these. Like for example, the addition property of equality. Let's say I'm giving you an equation and it's x minus 2 equals 5. When we go to solve this subtraction equation, we are using the addition property of equality. We would be adding the same number, and that's going to be my C and D that I'm adding to both sides, and that would give me still an equivalent equation. So when I solve equations, I'm using these properties of equality. I'm either adding the same number to both sides, subtracting, multiplying, or dividing. Now, when we go to use these in our proofs, we're baby stepping into proofs here. When we go to write these properties as a reason, I want to see you write addition property of equality. Now, if you want to abbreviate and just tell me add POE, and the P stands for property, the O stands for of, and the E stands for equality, you can add POE to the end of any of these words. So you need to specify that this is a property of equality when we're justifying our steps. And we're going to see what this means in a minute. Everybody good on the properties of equality slide? All right, let's try the next one, more properties. These are still properties of equality. The first one is the substitution property. And what this states is if A equals B, then either A or B may be substituted for the other in any equation or inequality. So for example, if 2A equals 10, and then if 2B equals 10, I could substitute either one into the equation because they're both the same thing. I could either substitute B for A or A for B. The next property here is the reflexive property. And what you're going to see on either side of the equal sign is the exact same thing. Sort of think of this as like your reflection. You look in a mirror. You look in the mirror, you see yourself. So reflexive property, we could say 5 equals 5. That is your reflexive property. For the symmetric property, it states that if A equals B, then B equals A. You're reversing the order. So think of the word then here as like a line of symmetry. So we would reverse it. So here if I said if x equals 2, then 2 equals x. We're just switching the order, and this is like a line of symmetry. So you can sort of see how the 2's match and the x's match. The transitive property is like the law of syllogism that we saw and we took on the quiz yesterday. So notice we've got an overlap here of my b's. So if A equals B and B equals C, then I can conclude that A equals C. And then the last property is the distributive property. You probably have used that quite often, and that's where you would just distribute what's outside of the parentheses to what's inside. So for example, for the distributive property, I might have 2 and then in parentheses an x plus 3, and you would just multiply the 2 to the x and the 2 to the 3 and getting 2x plus 6. Yes? Reflexive is the same thing on both sides of the equal sign. The transitive has an overlap. A key thing to look for in the transitive is look for 3 pieces of information. The reflexive, it's like a mirror. It's going to be the same exact thing on the other side. Okay? So for example, an example of transitive would be something like this. Let's say I have if A equals 3 and 3 equals B, then I could conclude that A equals B. Notice again you got these overlapping. That's your transitive property. So transitive property, you need 3 pieces. 2 at the beginning and then 1 to come to your conclusion. So again, transitive is like the syllogism law. Now, we're going to take all of these algebra properties and we're going to apply them all to geometry. So we're going to be applying them to segments and to angles. So over here on the left column, these are my properties. Over here, these are an example of segments. And this would be the column for the angles. So we saw the reflexive property. We could apply it to numbers. We could say 2 equals 2. Or we could even apply it to variables and say x equals x. Now here is an example of a segment DE and a segment equal DE. Again, for the reflexive, it's like a mirrored image, reflection. Same thing on both sides of the equal sign. Same thing here with the angle. You could have also said like angle A equals angle A. You could abbreviate the word angle with the symbol for angle. Again, for symmetric, again, remember it's going to be like a line of symmetry or the order's flipped. So again, I might have x equals 2. Or if x equals 2, then you could say then 2 equals x. Again, like a line of symmetry. And you would do that for both segments and angles also. And then again, the transitive is going to have a 3rd piece. So I did the example before with the algebra, but here we go again in this column with the segments. Notice the CDs overlap, and then you can go from the beginning to the end. Same thing for the angles. The angle B's overlap, and then you go from the beginning to the end. So just like the law of syllogism. So let me draw an example with some segments here. So let's say I draw you a segment, and if I say A, B, C, D, E, and F. I'm going to exemplify this statement here. So if AB, here to here, is equal to C to D, so I'm putting the same kind of congruency mark, and then if I'm also told that CD, the same segment here, is congruent or equal to EF, I can show that, let's say if I give them numbers, let's say this one is 5, so then I know that this other red one is 5, but because the red one is the same as the blue, it's also 5, and now I could say that this one's also 5. So this one, see how I've circled it with the 2 colors? This is where it overlaps, and then you can conclude that AB is equal to EF. So again, you're going to have an overlap, just like the law of syllogism. Let's try justifying each statement with a property from algebra or a property of congruence or a property of equality, either way. So, what is number 1? Which property are we doing there? Or is that demonstrating? Notice the overlap, or there's no overlap. It's actually like the mirrored image. So if I draw a line through here, this is the symmetric property. Again, don't get confused with transitive. Remember, transitive needs 3 pieces. Anybody know what's happening in example 2? Yes. Distributive. Good. Okay, then number 3. Anybody know what's happening here? Now, I do have 3 pieces here, but if you notice, they're telling me that if 2a plus b equals 24, and then they're telling me what b equals, I'm going to take this b out and put that into it. So there's my new equation. So this would be substitution. And the last one, what did they do to the x over 3 equals 12 to get x equals 36? They used the multiplication property of equality. And I'll abbreviate it as POE. Remember, this stands for property of equality. So make sure you add that into the end. The next example, they have taken an equation and they've solved it for x. What we're going to do is justify each step and give the reason as one of the properties we just learned about. So in example 2, this is a mini proof here. Now, what we're going to be doing in this course is writing 2-column proofs. So it's not going to say justify each step, it's just going to say prove. So you're going to have 2 columns. The first column is going to be your statements. And the second column is going to be your reasons, or this is where we would justify. All right, so the first, number 1, this one is the problem that I'm giving you. So this is given. Generally, your first statement in your proof is going to be given. Now, we have to describe what we did to go from step 1 to step 2. What did we do? Multiplication. So we applied the multiplication property of equality. We multiplied both sides by 3. What did we do from step 2 to step 3?
Distributive.
Beautiful. We did the distributive property. And what did we do from step 3 to step 4?
Addition.
Beautiful. Addition property of equality. And lastly, from step 4 to step 5, we used division property of equality. So our beginning proofs are just going to be basically solving an algebraic equation. You will have to show step by step and describe what you're doing in each step. So you will have to justify each step. Yes?
Can you put it like that, or do you have to like explain that you would have to multiply this and that?
You would just write the property. Okay, so again, I know your slides end at a page to your Notability or wherever you're taking the notes. We're going to do one more. We're going to set it up the same way. I'm going to give you an algebra problem. you're gonna solve it and justify each step. So let's try it. So again, we are going to solve phi. So we're gonna write our statements. And then we're gonna write our reasons of why we did what we did. So here is your problem. It's 1/2 x minus 3 equals 10. So this is the problem that I gave you. So this is given. First, do what he said, and then we're gonna do the adding 3 method. So some Algebra 1 courses teach you to clear all the fractions first. So what I could do here is multiply everything by 2 and get rid of the fraction. So this would be multiplication, property of equality. Then next, what I can do is add 6 to both sides, and this would be the addition property. So this is one method. Now again, we could have also not gotten rid of the fraction first, and we would add or subtract first. So this is one way. So what we're gonna find is when we're writing our proofs, there is gonna be different ways to solve them, and depending on everyone's logic. So let me show you the same problem. Again, statements, reasons, same problem, 1/2 x minus 3 equals 10. This time, instead of getting rid of the fraction, I'm going to add 3 to both sides. So here, we're gonna add 3 to both sides. So 1 was given, 2 is adding 3 to both sides. Now, again, we're not actually showing this, but if you wanted to, for your own purposes, show that you're adding 3 and that's how you're getting there. So this is the addition property of equality. And then next, we would be multiplying by the reciprocal to get x equals 26. So this would be the multiplication property of equality, or POE.
Miss Corey?
Yes.
So every time we get a problem, we have to do what you're doing?
Yes. So again, when we divided fractions, we're multiplying by the reciprocal, but let's say our problem was 2x equals 10. To get to the next step, x equals 5, we're doing division property of equality. So again, if you put this as division, that would be fine, but again, technically what we did was multiply by the reciprocal. All right, so you do have homework on this. It is the 2-5 homework. It's the PDF that's there. It's the textbook problems. So that is your homework tonight. When you come in tomorrow, you're gonna work on the warm-up for 2-5. We'll go over the homework, and then tomorrow we'll learn 2-6. And then Friday 2-7. Monday we will review, and then Tuesday is your test. Now over the weekend, I'm gonna probably be giving you the 2-7 homework and the chapter review. So you can start looking at this, because again, it's 7 lessons. So we've learned a lot of definitions, a lot of postulates. So you should be looking at this over the weekend.